Your snake plant, officially Dracaena trifasciata, though most still call it Sansevieria, just grew a flower, and if you've seen it happen, you already know the feeling. A thin spike rising from the base, carrying dozens of tiny buds, and your first reaction, almost certainly, was not excitement. It was worry. Nobody ever mentioned this plant could do that, and the gap between what you expected and what you found sitting in your living room is exactly what this video is about. What makes it genuinely worth staying for is this. The International Sansevieria Society, the official body dedicated to studying these plants, released a position on what that flower means for your plant's survival that contradicts almost everything the internet tells you, and we'll get to that answer in a few minutes because it reframes the whole picture. The place to begin, though, is with the disagreement that scientists themselves have been unable to resolve, because that disagreement turns out to be the entire story. The snake plant has been confusing botanists for a long time, not just gardeners. Carl Linnaeus, the man who built the modern system for classifying living things, cataloged this plant in 1753 and grouped it with aloe, which made surface-level sense since both store water, both survive drought, and both have thick, waxy leaves that feel almost artificial to the touch. The grouping was wrong, and 2.5 centuries of scientists worked to sort that out. In 1903, botanist David Prane, who would later become director of the Royal Botanic Gardens at Kew, formally placed the plant in a genus called Sansevieria, a name chosen to honor an Italian prince and inventor named Raimondo di Sangro, the Prince of Sansevieria, who lived from 1710 to 1771. He was not a botanist. He was a patron, the kind of figure who ends up attached to a plant's name because he had an impressive garden and scientists of that era needed support. Then, genome sequencing changed everything. In 2017, after molecular phylogenetic studies carried out at institutions including the Royal Botanic Gardens at Kew, scientists made a call. The snake plant belongs in the genus Dracaena. All 70 or so species that had lived under the Sansevieria name were folded in because at the genetic level they were too closely related to justify keeping them separate. The official name became Dracaena trifasciata, and Sansevieria was retired from formal use. The plant community was not unanimous in its approval. Critics pointed out that Dracaena plants grow on thick stems with a distinctly tropical character, while snake plants produce stiff, sword-shaped leaves that store water like a vault, and putting them in the same genus on the basis of DNA while ignoring everything visible seemed to many growers like an overcorrection. Many nurseries never updated their labels. Most plant owners still use the old name. This video will too, because Sansevieria is what most people searched for, and the name points to the same plant regardless. What that long history of misclassification actually tells us is something worth holding on to. This is a plant that resists simple categories. And that quality, it turns out, applies to its flowering behavior as much as it applies to its taxonomy. Native to West Africa, specifically to regions like Nigeria and the Congo, the snake plant evolved in a climate that is hot, dry, and genuinely unforgiving, which is why it handles a dim apartment without complaint and forgives weeks of missed watering without showing any sign of distress. That endurance is real, and it comes from a long history of surviving conditions that would finish off most other houseplants. Interestingly, this same resilience made it one of the plants featured in NASA's Clean Air study for its ability to purify indoor air, adding another layer to its reputation as the perfect low-maintenance houseplant. Plants that evolve under harsh conditions tend to develop one specific survival mechanism. They bloom, and the reason they bloom connects directly to what we're trying to understand here, but explaining it means laying out two theories that genuinely contradict each other. The older and more established theory holds that blooming in the snake plant is a stress response. When conditions become unfavorable, when roots have packed a pot so completely that no expansion is possible, or when water has been scarce long enough to feel like a real threat, the plant shifts its strategy. Energy that would have fed new leaf growth gets redirected toward reproduction instead. A flower spike rises, the flowers open, release fragrance to attract pollinators, and if successful, the plant sets seeds. What the plant is calculating, in purely biological terms, is that its own future is uncertain, and ensuring the next generation is the better investment. That reasoning fits the plant's evolutionary background perfectly. In the wild, drought is not hypothetical. A plant that reads environmental pressure as a signal to reproduce right now rather than waiting for conditions to improve passes that strategy to its offspring. The ones that waited may not have gotten another chance. Here's the thing, though. As indoor plant ownership expanded and more growers began documenting their blooming snake plants online, a different picture started forming. The plants showing up in those photos were not struggling. They were well-watered, bright-lit, carefully tended plants putting up flower spikes with no sign of stress anywhere. Experienced growers began pushing back on the distress narrative, and the counter theory emerged. Flowering happens when a plant is particularly healthy, settled, and mature, not when it's afraid for its survival. One writer documented his snake plant in Lima, Peru, a city that receives less than 1 inch of rain per year and uses snake plants as standard outdoor landscaping. His plant had recently been separated from new pups, was growing rapidly, and showed every sign of genuine health. When it bloomed, he asked whether the idea that only struggling snake plants flower might be, in his word, jealousy. The honest answer, and the most accurate one based on what the evidence actually supports, is that both conditions can produce blooming. Mild stress can push a plant toward reproduction. A mature plant with enough energy surplus can also flower without any stress involved at all. These are two different paths arriving at the same result, and the science confirms that the process remains genuinely not fully understood. Before we get to what actually happens to your plant after it blooms and the myth surrounding that which needs to be put down directly, it's worth spending time on what consistently appears in documented blooming cases, because that information is practical and specific. Light matters more than anything else here, and this is where a great deal of confusion lives. Snake plants get sold with a low light label, and that label is not wrong exactly, since they do survive in dim conditions, but surviving and blooming are two completely different states. To produce flowers, a snake plant needs real and abundant light. Growers whose plants bloomed place them beside glass patio doors with direct east-facing sunlight, or in large eastern exposure windows where direct sun reached the leaves for part of the day. The underlying reason involves the difference between what indoor filtered light delivers, which covers only 2 or 3 wavelengths, and what full outdoor sunlight provides, which is a complete spectrum. That gap in light energy almost certainly explains why blooming happens far more often in plants kept outdoors and far less often in the ones placed in corners where they'll tolerate the conditions but never truly thrive. Maturity is the second consistent factor. Most snake plants need to be at least 3 to 5 years old before flowering becomes realistic, and younger plants simply do not have the developmental foundation for it, regardless of how well they're cared for. Root-bound conditions show up in nearly every documented blooming case as well, whether interpreted as a stress trigger or as the natural state of a mature, established plant that has fully claimed its space. Either way, the correlation holds consistently enough to treat it as a real factor worth paying attention to. Watering rhythm also plays a role, specifically allowing soil to dry out completely between waterings in a way that mirrors the plant's native dry cycles. Overwatering works against blooming in a straightforward way. One more thing deserves mention here, particularly for anyone who has spent money on a bloom booster fertilizer. It will not cause a snake plant to flower. Environmental conditions and light determine whether blooming happens. Extra phosphorus left behind in the soil by those products does not substitute for those conditions, and what it does leave behind is mineral salt buildup that the plant does not benefit from. Now, for the myth that needed its own section, when a snake plant flowers, a meaningful number of plant owners immediately want to cut the spike off. The reasoning comes from the concept of monocarpic plants, which are plants that flower once and then die. Agave is the most famous example, spending decades growing before sending up one enormous flower spike and then finishing entirely. People apply that logic to snake plants and respond accordingly. The International Sansevieria Society addressed this directly. Snake plants are not monocarpic in the traditional sense. The specific rosette, meaning the individual cluster of leaves that produce the flower spike, will not generate new leaves after blooming, and that part is accurate. What does not happen is immediate death. Those leaves stay healthy and visually attractive for years after the bloom. The root mass continues producing offsets, new pups, new rosettes around the original. One grower who tracked his plant for 3 years after it bloomed found every original leaf still intact, in exact agreement with what the society described. The blooming rosette is not ending its life. It is passing responsibility to the growth it has already produced, and the plant as a whole continues forward. What the flower does during its brief appearance connects back to the plant's evolutionary origins in a way that's easy to overlook. The flowers open at night and close during the day because in the wild they are pollinated by moths. This nocturnal blooming pattern is actually part of their CAM photosynthesis system, crassulation acid metabolism, which allows them to conserve water by opening their stomata at night instead of during the hot day. The fragrance they release, described by different growers as honeysuckle, lavender, vanilla, banana, and grassy, depending on the variety and the person, gets released specifically at night to reach those nocturnal pollinators. The chemical profile of just one variety's flower scent, the Sansevieria trifasciata Laurenti cultivar, contains approximately 69 distinct compounds including esters, alcohols, and aldehydes. This is not a simple smell. It is a precisely constructed nocturnal signal that natural selection has been refining for an enormous stretch of time, and it is currently operating in your living room. What this all adds up to is something worth sitting with. The snake plant is not dying when it blooms, and it is not necessarily telling you something went wrong. What it is doing is exactly what it evolved to do in the dry, rocky stretches of West Africa, which is making a biological calculation about when to reproduce, triggered by some combination of age, light, root conditions, and environmental factors that science still does not have a complete account of. The mystery has not been solved. These plants live in our homes for years, tolerate neglect with patience, and ask almost nothing of us. Then a flower spike appears one ordinary morning, and it turns out the plant has been navigating survival decisions quietly all along, using systems built long before anyone thought to put it in a pot. When yours blooms, move it somewhere with more light and let the flowers open after dark. Put something beneath the stalk because the nectar drips and it is sticky. Do not cut the spike off in a panic. The International Sansevieria Society has been clear. The plant is not ending. It is, in its own patient way, beginning something new.